Uh, Good morning, everybody, and welcome to Google. So I'm happy to kind of give the first talk. To kind of get a sense for the audience, though, I wanted to get a show of hands, kind of who considers themselves data scientists? Everybody, hopefully. I guess I'm not sure where to draw the line, but like, who does machine learning? A bunch of people too. And then applications to language, so natural language processing. Fewer. OK, that's what I assumed. At the same time, I work on NLP, and that's what I know. So I'll talk mostly about machine learning and data science applied to language, with a focus on what we can do with large amounts of data, and whether data is going to be enough, and we can just do unsupervised learning, or how much supervision we can get and or need. And so my premise will be that we will need some human input, and just raw data might not be enough. But before we start, Minerva did a nice introduction, actually. I like to kind of contrast how reality looks and what Hollywood tells us is possible. And so in the 80s, we had already computers or robots that could talk and understand us. But the reality was a little grimmer. People were writing rules and were trying to encode the human knowledge in rule-based systems. And those were brittle. Computational power wasn't quite there. And there was the AI winter where lots of people got disappointed. Then in the 90s, we had self-driving cars that could talk in the movies. But in reality, like personal computers were starting to appear. Statistical approaches were starting up. And so I think those are sort of predecessors to what we currently do. But the problem was that we didn't have enough data. And we didn't have enough compute power to actually build applications that kind of could be ubiquitous the way they are today. And so then in the 2000s, computers had feelings, and then people got scared that the artificial intelligence is going to take over. But in reality, we started to find ourselves using artificial intelligence, machine learning in our day-to-day lives more and more. So Google Translate, I assume most of you have used. Speech recognition. Try it out if you haven't tried it recently. The quality has gotten really a lot better over the last year or so. Error rates have been cut by more than 30%. And even for me as a non-native speaker, my phone tends to recognize what I say. And I can do maybe short dictations, or just simple question answering works remarkably well. And I'll show some examples of that towards the end of the talk. And we now also have self-driving cars to some extent. I think the technology is pretty much there. It's on the regulators to figure out how to put these cars on the street in a safe way, and to figure out the legal framework. And you've also heard about kind of Google Brain, machine learning at large scale applied to lots of places. So I was going to look now at kind of some examples in NLP, and we can see sort of where the state of the art is, what can we do, and what is missing. So if I give you this article, recent news about Volkswagen. I grew up in Germany. You've probably heard about them cheating. And I wanted to see what the French people think about it. And so I went to Le Monde. I know it's a French newspaper, but I don't speak French that well. So if I look at Google Translate, I can actually make sense of this, and it sounds quite fluent. So the scandal of Volkswagen shock, a little disfluent, but then shockwave continues to spread. Friday night, the Swiss authorities have announced to suspend the sale of new diesel models of the group, potentially equipped with motors rigged and able to distort the emission tests. Not bad, right? So one could think that machine translation is basically solved if one looked at these two examples. But we'll see shortly that that's not the case. Before that, I wanted to take a detour, though. How many of you know what's happening behind the scene and how these systems are trained? Very few. Cool. So I can teach you something. And we'll do it with a simple anecdote, but it should get you kind of give you an understanding of what's happening behind the scenes. So if I ask you to translate between these two made-up languages, Centauri and Arcturus, and there's the sequence of characters. I've been nice and put white space to separate the words for you, and ask you, can you translate this for me? Well, it's a made-up language. Nobody speaks it, so no, you can't. But if I give you a parallel corpus, so sentences that are translations of each other, and you can use that to translate now and kind of use it as a puzzle to figure out what's going on. How would you do it? Well, you would probably look at the first word, Farok, and try to find it in the text. And so it happens to appear twice in the text. And if we look at the translation, there's only one word that appears in both translations, and it's this word jat. So we can't be completely sure that that's the right translation, but it's quite likely. And so we can go through, and then we can look at the next word, Sarok. Well, we're unlucky here because it appears once, and so any of the words on the other side could be the translation. We could maybe say it's going to be in a similar position, kind of maybe it's the third word again, but who knows? So let's continue and see whether we can eliminate the possibilities by aligning the other words. And so if we look at Hihok, we actually see that Arad is the word that appears always with it. So that seems to be the translation. And so if we keep going like this, we can align all the words and get probabilities or kind of correlation statistics of how words might translate to the other language. It's not going to be perfect, but it will give us a signal. And so that's the basic kind of idea that has been around since the 80s for how to do statistical machine translation, late 80s, early 90s, I should say, and is the foundation of modern statistical systems. And so it involves not just kind of these correlations the way I described them, but the YAM algorithm, if you're familiar with it. And people have done many extensions, but that's basically what we do. And so once we have these alignments, we can extract the dictionary of words or phrases and how they translate. And then we can put together the translation. In this case, we actually, by elimination, figured out that Sarok doesn't align to any word and should be dropped, because sometimes words just don't get translated, articles or something like that. Now, the question is this a grammatical translation? Do we need to change the word order or not? And that's something that we'll get back to. But before we get there, I'll just show you sort of the power of data. Depending on how much training data we have, how many example sentences we have, we can measure the quality of the final translation system. And so, oh, I'm missing the legend. But there are 4 different languages here, Portuguese, French, German, and Chinese being translated into English. And on the y-axis, we have the translation quality measured by an automated metric, and then the amount of training data we have. And so if we start with 1 million sentence pairs, we get these scores. When we go to 10 million sentence pairs, everything gets better. With 100 million sentence pairs, things get even better. And with 1,000 or billion sentence pairs, things get even better. And so the plot is a little misleading. You're looking at this linear slope, but it's logarithmic on the x-axis. So it's a factor of 10 increase of the data. Nonetheless, you might say, well, if we keep kind of increasing the data by a factor of 10, maybe we'll get to human-level translation. And some people believe that. I'm a little skeptical that just more data is going to cut it, because languages are not just kind of random sequences of words, and there's a lot of subtlety, and there's a lot of structure in it. And so we should try to take advantage of it. And so to show you that kind of just a lot of data is not going to cut it, here is an example for a Japanese translation. And again, I tried to find something about Volkswagen. So I was able to identify an article, but sorry, I actually don't know what this means at all because I can't even read the characters. And so if I pipe it through Google Translate, we get the following translation. Germany Volkswagen of VW emission regulators in the wrong issues surrounding the company South Korean corporation is September 30th, Beetle Golf, such as 28 models, meter about 12 million units of passenger car recall. So like you always, like you start reading and it sounds reasonable and then it just changes completely. And then you get into the next phrase and it looks reasonable and then it's again shuffled completely. And the problem is that the Japanese word order is so different from the English one that if we just do small local reorderings on the word order, we're not going to get the fluent translation out of it. No matter how much data we have, I don't think we can learn to automatically reorder this. And as a kind of just high-level example, in English, you typically have the subject and the verb and then the object. In Japanese, it's subject, object, verb. And so we need to identify the verb and move it into the right position, because if it's at the end but needs to be at the beginning, it's going to be very hard otherwise to get the grammatical sentence. And without knowing what verbs are, we can't do it. So this system actually already uses some syntax, but obviously there's lots of work for us to do. And so the way that we do it in kind of at a high level is that we take a sentence, and in addition to figuring out what are the words, once we translate them, we need to put them in the right order. And so I'm showing a German example here because we speak German. And if you wanted to take the sentence, she can eat pasta every day, in German, you would take the verb and move it to the end, similar to the Japanese case. And now we can translate this reordered sentence, and the grammar on the German side will come out better. So you might say, well, we can write a rule. That's pretty simple. Just take the verb and move it to the end. Once you have analyzed the syntactic structure, this grammar of the input sentence, you can do that. Well, language is fairly flexible and has always exceptions to the rules and exceptions to the exceptions. So if you make the sentence be, she believes that she can eat pasta every day, well, now you need to take not just the eat verb and move it to the end. You also need to take the modal can and move it with it to the end, but then flip their order. And so all these patterns, like, we need to learn automatically, but I think we need to sort of get familiar with the data. Just, it's not going to jump out at us. Like, we need to understand the phenomena. We need to learn about the problem, bring in some linguistics to it, as well as machine learning, and lots of data to observe these patterns, because we cannot dream them up. And then we can hopefully make some progress on this problem. So how do we do this? Well, as I said, we use syntax, because if we just try to find a random permutation of the input sentence, that can be reduced to a traveling salesman problem, which is NP hard, and you don't want to do that. That's hard. So we need to limit ourselves to what the possible permutations are, which are allowed, and then score those and figure it out. And we have done a bunch of work in this area. So switching gears now, if we kind of, assuming we can analyze what are sort of the nouns and verbs and the grammatical structure of the sentence, what about more semantic things, like understanding entities and their types? So Bourdain reviewed Alinea carefully last year. We can figure out that, oh, Anthony Bourdain is actually a person. He has a Wikipedia page. Freebase is a knowledge base where things are grounded, and we can link up Bourdain to that. Note there, Alinea, or Linea, I don't know how to pronounce it, is a location. It's actually a restaurant. And we can figure that out. There's some ambiguity, because the same string of a name can apply to multiple places or entities, but we can figure it out relatively reliably if it's a well-known entity. Furthermore, we can take the pronoun he and, based on the context, figure out that it's probably referring to Bourdain, because Bourdain is a person, while Alinea is a location, and therefore we wouldn't want to make it co-referential. We would say there or here to refer to that. And so One thing that we want to do beyond the common entities is, though, to analyze rare entities. And so here's a snippet from a newspaper text. And we can identify that there's this entity, Andrew Burnham, and we don't know necessarily what it is, but probably we can guess that Andrew Burnham and David Kinch are names of people because we have seen Andrew and David as names. But Bywater, well, I don't know what it is, Big and Easy Manresa. So detecting the boundaries of these mentions is not like super hard. We have capitalization and other cues that help us. But then figuring out the types is actually something that's quite difficult because there's just lots of names and it's hard to know what they are. And so this would be the labeling. To produce that, we use, again, large amounts of unlabeled data with a small amount of labeled data to try to bootstrap our way out of this problem. And so what we do is we take a bunch of text and from news and the web and analyze it with our system. It's called SAFT. And so given this analysis, we can then extract the boundaries for the mentions and build a graph based on contextual similarity. So we can see that David Kinch appears in similar contexts as Daniel Patterson and Thomas Keller. And these edges on this graph will have weights that correspond to how similar the contexts are where things appear. We'll prune unlikely edges so that it's not a fully connected graph. And then if we have some human supervision, for example, for common entities like Thomas Keller, we can label them with the correct label. And then we can run graph label propagation to smear the label distributions over neighboring nodes, because the assumption is that entities that appear in similar contexts will have similar types. And so instead of having to go through and label all entities out there in the world, we can just get some seed entities that we can label reliably and then use semi-supervised learning to extend this information to other entities. So that was an animation that I forgot. All right. So as I said, figuring out what the entities are is non-trivial, but relatively easy. Like, there's not that many ways to refer to Mona Lisa or Leonardo da Vinci. And so I just assume that this can be done. One thing that we're working on now that's a little harder, but I think is going to be needed for certain applications of language understanding, is to try to understand how people refer to the relations between these entities. So if we have a knowledge base, like a knowledge graph, the way Google talks about it, Freebase, or whatever representation you want to have, you need to come up with a schema and describe how the entities relate to each other, given fixed relations. But natural language has many ways of referring to the same thing. And so figuring out how people describe the relations between these different entities is quite difficult. So as an example here, a couple questions that all should give you the same answer. Which university did Obama attend? Which university did Obama go to? Which university did Obama study at? Which university is Obama's alma mater? And so on and so forth. And currently, Google handles several of them, but not all of them. And the problem is that there's just an infinite number almost of ways to express this. And so we are pursuing some approaches to try to learn how to do this grounding by looking at entities and the relations that are between them, how they're expressed, and then doing some linguistics, some machine learning, some data munging, and then trying to learn ways that things can be expressed, so that if you, in the future, come and ask a question like, which university did Obama and his wife attend? We can figure out several things. We can figure out that his wife refers to Obama, and his wife is Michelle Obama, so we can ground the two entities. And then university and attend is the educational institution relation, and then there's this conjunction and, so we want to find the intersection of the universities that I attended and return you the one correct answer, which is Harvard Law School in this case. And so this is not launched yet, but we're working in this direction. What is launched, on the other hand, and I encourage you all to try it out, is just to talk to your phone and ask questions the way you would ask your friends. So who is the chef at the French Laundry? It's a restaurant in California, quite tasty one. And one thing that will happen in the background that you won't see is it will do this analysis from a linguistic point of view and figure out, OK, there's the chef is a noun, and additionally, we also know that the French Laundry is an entity of type location. So in this particular setting, this will be just kind of analyzed. It won't necessarily affect the results because the result is fairly clear. It's Thomas Keller. And so you'll get the result. But then what we'll do is we'll actually remember that Thomas Keller is now in the context of your session. And so if you ask, as well as the French Laundry, and so when you ask what are its hours, something that few people do nowadays because you might not expect this to work, but it does actually work and it's been working for a year, is you can get the answer because we will analyze it and we'll figure out, oh, there's this pronoun, it's. What can it refer to? Well, nothing in the local context can be grounded to it. But if we look at the previous query in the session, we know that there are these two entities, the person Thomas Keller and the location French Laundry. And so given that it's a neutral pronoun, it probably refers to the location. And therefore, we can retrieve the correct answer, 530 to 915. If we ask what books has he written, on the other hand, we know that he, again, must be referring to something in the context. But it's unlikely that he's the French Laundry. It's more likely that it's Thomas Keller. And so we'll get you the correct answer, which is the list of books that Thomas Keller has written. And so using context and pronouns is something that you should periodically try because we're experimenting and launching new features all the time in the space. It works for spoken queries, both on the phone as well as on your desktop, if you want to speak to your desktop. So to leave some time for questions, I think data is very important, and it's a big building block when trying to build systems. But we need to think about how we can bootstrap our way out of it by using data to build systems that can analyze data that can then be used for further training the systems. And then something that I didn't talk much about, but is also very important, is then to work with the user and harvest user interactions. When you search on Google and you click on the third result, we can learn from that the first two are not so good. And so similarly, in many settings, when you have a machine learned system that users are interacting with, we need to harvest the user interaction as a signal that can produce additional auxiliary data that we can use to train better systems and thereby try to get closer to understanding the world and building something like artificial intelligence, whatever that may be. So thank you. Any questions? Yes, please. It's hard to see from here because I have the lights on me.
I didn't think I needed this, but OK. What do you think will happen with SEO and SEM given conversational search?
That's something that I personally don't tend to worry about too much. I want to provide users the right answer. And that's for sort of these fact-seeking queries. That's definitely the right thing to do. If you're searching for products, that's an interesting question. But currently, we're thinking primarily about factoid questions or just general questions that are not sort of product-seeking. And there, I think giving users the right answer is the main focus. And there's enough other queries that will make sure that my salary can still be paid. Just speak because I really don't see anything.
wait for the mic so people online can hear too. But so there's things like Duolingo that are available for that allow for translation by people as a part of their language training. How have you been exploring leveraging that kind of technology as a way to provide additional data to be able to like have additional translations of sentences?
So I guess there's Duolingo. There's a friend has a company called Unlabeled where they're trying to use human computation for improving translations and crowdsourcing them. I'm not sort of a core member of the Translate team to comment on it. I can tell you sort of that we're trying to harvest signals from suggesting better translations. And there you might have seen like over the years, people have tried different things, from just allowing people to edit the translation to being able to select between multiple translations to drop-down menus with alternatives. And all of these things, like they're experiments to figure out how to best harvest the data. Because if you just give people a free form where they can edit stuff, it's too noisy. Sometimes it's just so far away from what the current system is predicting, or it's just spammy. And figuring out how to kind of separate signal and noise is really hard. And so putting some constraints is important. I think the other thing is figuring out how to sort of, most people will get the translation and copy paste it into some other place and edit it there. And figuring out how to actually learn from that, I think is a very interesting and challenging sort of infrastructure human-computer interaction problem. But I don't think we have a final solution. And overall, yeah, I think as long as you can get the incentives aligned so that users solve the task that they're trying to solve and as a byproduct produce data that's useful, we can have a win-win. Duolingo has that premise, but it has gotten fairly quiet around them. I don't know sort of what's going on. I think people are very excited, and then at the end, it's tedious to learn a new language, and so people give up. Other questions? Yeah.
So, how do you know what's the right scale where to stop this process? Because you notice that the word by word doesn't work, so you kind of expand to sentences. But sometimes in languages, that's not going to be enough, right? You're going to maybe need a couple sentences to make sort of another sentence out of a couple. Like, what's the right cut point?
So the question for those online is that what's the right unit? I showed that words are not enough and focus on phrases and sentences, but maybe you need to go to paragraphs or some larger unit to provide a meaningful translation. And it's we've done experiments, and most of the information is typically contained in a sentence. In some cases, for pronouns, for example, it might be ambiguous given the context, because in one language, you might not distinguish between different genders of the pronoun, but when you translate it, you need to predict the correct gender, and that might not be available in the current sentence. You need to look back. And so some of the examples that I showed about coreference resolution, we have some experiments that we want to do in the space to see whether we can improve it and also make it more consistent between formal and informal pronouns and things like that. But sort of to be able to translate Shakespeare, we will need to look at more than just a sentence. But for most practical purposes, sentences seem like a reasonable unit to operate at for both computational reasons and sort of getting the gist of it. But yeah, for perfect translation, we might need more context. All right, we have another minute.
So I know there's a lot of made-up languages from linguists that are supposed to be very easy for anyone to learn. What are kind of the challenges for creating translations to these made-up languages and then going from the made-up languages to any other language?
Yeah, I mean, I guess one could try that. One could try to just kind of create the ultimate interlingua language, which would be some type of semantic representation plus. The challenge is oftentimes that what I showed, kind of data. If you don't have enough data, even if the language is simpler, you're not going to be able to translate well into it. And if you compare the kind of translation quality between different language pairs, sometimes you see that even for closely related languages, if for political reasons, for example, there's just not that much text in both languages, the translation system is actually worse than for some languages that are further apart. And so translating into these made-up languages where we basically have no data is going to be very hard. And at the end of the day, like, even if it's a simpler language, there's a lot of information that needs to be represented, and languages are so complicated because there's lots of nuances. So we'll lose some nuances, I think, if we try to come up with some generic intermediate representation. But that's my take.